Welcome to our February Cloud Leadership Circle meetup. And we have Adam Robertson. Adam is here presenting at Cloud Leadership Circle for the second time. He is a vet in our circle. And fun fact, he holds a record for the highest viewed talk at CLC. So let's hand it over to Adam.
All right, no pressure at all there. Okay, great. All right, let's, okay, so today, just gonna dive into a bit about AI infrastructure and architecture. So I do like just a couple caveats. We have 10 minutes, so can't dive too deep. Also, a lot of these things are problems without solutions, which I generally don't like, but they are problems without solutions because they're new and they're really complex. So that's kind of why we're here, to talk about them, so we can all kind of work on them together. So in the bottom right throughout the slides, you'll see ways to connect with me on QR codes, and feel free to do so. Love to hear from y'all. So the quick agenda, we'll go on just who I am and why I have any right to speak about this kind of stuff. And then we're gonna just go briefly into traditional DevOps architecture, and then moving to AI architecture with some examples. So first, I've had the joy of working for some really exciting startups that just exploded into scale, and varying scales in various verticals. So I've in all these companies, I've had the joy and privilege as well of managing all the infrastructure. And so I've had a pretty long tenure of working with traditional companies, as well as most recently in the last couple of years working with AI-based companies and implementing the architecture and the patterns design and implementation as well. And got the joy of speaking on panels as well. And like I was able to, I published a couple of books last year, which is really fun. Feel free to check those out. That's the bottom right QR code if you're interested. And just recently joined the Miriam Labs as the head of AI infrastructure. So I'm going fast through these because time. So what are we talking about today? So what is it you'd say you do here? So specifically, I want to talk about AI infrastructure and architecture, and some of the patterns that we see, some of the differences that we see. And that's really what I kind of want to focus on, is the realization that with the AI ops and ML ops coming up as kind of the next iteration of DevOps infrastructure management, there's some changes that people really should be aware of, and I don't think that everyone really is at this point. And so raising awareness about that, I think, is important.
Cloud Leadership Circle is brought to you by InstaQuery, the AI-powered SQL optimization platform that delivers smarter queries and faster insights. With over 50 specialized agents, InstaQuery dynamically tailors LLM-powered prompts to rewrite and optimize SQL queries with 100% accuracy. Boost productivity by 500% and transform the way your data team works. Book a demo today at instaquery.ai to see it in action.
So when I say traditional, it boggles the mind, because I started doing, I think a lot of people here have been doing DevOps for a long time, and I would never think to apply the word traditional to DevOps, but here we are. So, these are the kind of core tenets that we see with DevOps practices and principles, right? We have a lot of automation, repeatability. Like, these are just core tenets that everyone is aware of. We've been practicing these for a long time. They're tried and proven, and the benefits from them are very evident, both in business metrics as well as engineering metrics as well. And I think a lot of people have gotten really comfortable in these paradigms, and people have gotten really good. Large companies are established at $1 billion companies that do these things, right? So this is nothing new for a lot of people. And what ends up happening is that comfort level, once established, they start to apply it to new things, and they start having bad time with that, because traditional DevOps is not necessarily the solution for what we're seeing in modern day AI and ML ops. And so in traditional, so for moving now to their AI and machine learning architectural patterns, the problem isn't just our, hardware underutilization or cost inefficiencies, right? It's that infrastructure teams aren't adapting to AI's unique demands. So some quick things we can point out here is training and inference. I think everyone kind of has a good understanding that these are two different segmented patterns, and they have different requirements. Just classically, training is going to be a different iterative process. It requires different set of hardware. It requires different set of underlying file systems to support the massive amounts of data. Oftentimes we're seeing that people are trying to separate these environments because of cost measures, right? AI workloads require distinct environments for large scale training versus low latency and high throughput inference environments. But a lot of infrastructure teams still treat them the same. So you end up having degraded experiences on both sides because you're not optimizing for either side. Another issue with that is, of course, if you have to move an insanely large model or insanely large amount of data, you incur an insanely large bandwidth bill and storage bill. So, these traditional patterns don't work for, split environments where you have distinctly different requirements. And we, of course, move to scalability and optimization. So inference workloads are bursty and dynamic, right? This is not the classic, usage pattern that you're going to see. But infrastructure is still designed, or some people are still designing it for classic provisioning, and it leads to wasted resources. So whether it be you're scaling, you're using traditional things like auto scaling in AWS, or with Kubernetes, you have Kita, or even their horizontal pod autoscaler, whichever you're using. These are traditional methods of scaling for predictable growth or change. It used to be you could look at the last 3 months, you have a pretty good idea of your usage patterns and your number of users, and you're able to forecast and understand where your infrastructure is going and build accordingly. That is not something you can typically do so much anymore with different usage patterns and different resource requirements as those usage patterns change, and they change a lot faster than they used to. So, when building infrastructure, you have to take that into account. And when you're actually having to answer business stakeholders, and especially about cost, it's increasingly more difficult to do that with a higher level of confidence because of that unpredictability. And we'll get into some of the factors that come into that in examples. But this is a pain point that people may or may not be aware of, but they're becoming aware of it when they are spending a lot of money on training in instance environments, and they have to scale, and their scaling practices are not keeping up. And you're supporting AI and ML teams instead of classical engineering teams. Again, this is kind of an inertia problem. You're used to supporting, backend, PHP, Go, C++, whatever it is you're supporting, and those requirements largely they're not static per se. They do change from organization to organizations, but the themes stay the same. And within a company, if you've been in the company for a long time, you don't have change that often. You may upgrade point versions or minor versions of software, or every year or so a major version, but that's not a rapid iteration and a rapid change, versus AI and ML teams tend to change much quicker. The tool sets, just every day we hear some new tool that's coming out. And of course, you get a request to support that tool. Another difference between the team, which is really important, is traditional infrastructure teams assume highly technical users. These are engineers who know how their product works. They may not necessarily be completely comfortable with a platform on which it is running, like Kubernetes or any of the cloud providers, but they are highly technical. AI teams tend to be, primarily researchers or data scientists who need more platform-based solutions, right? So they're not low-level infrastructure people. They are looking for more tools, and that's a more platform engineering approach to be able to support them. And in DevOps and supporting central teams need to understand that. And we talked a little bit about data, but the AI workloads depend on high throughput data pipelines and specialized hardware, specifically GPUs and TPUs, right? Legacy infrastructure wasn't built for this kind of load. So we've all seen, and if any one of you is in charge of allocating instances on a cloud provider, you know how hard it is to get, a G5. You have to search far and wide sometimes they just don't have it. So your infrastructure requirements, where it used to be the cloud has unlimited supplies, that's not the case anymore. So you have to do kind of advanced planning, which takes advanced forecasting, which is difficult from the aforementioned points. So we're having a lot of problems just getting the machine learning teams or any of your stakeholders the actual resources they require, which is a big challenge, because that's fundamentally at the base level what your job is, right? And next is a fragmented ecosystem. This kind of goes to the rapid iteration of change. AI stack is a maze of frameworks. There's model formats, different APIs, different tools, and a lot of them are so new and they don't care about interoperability. So teams are wasting an enormous amount of time stitching together solutions instead of focusing on innovation. They're playing catch up. And for anyone who's been part of a team who's just, so enamored with the newest and shiniest, you are not going to have a good time in the AI ecosystem, because every day there's something new and you can't switch your team every day. And so a lot of people are having to change their even approach at supporting various tool sets in this ecosystem. So we can go to some little more specific examples in the time that I have left here. And so thinking about CI/CD, right? Classic, this is the core of DevOps. Most people, when you think of DevOps, are like CI/CD. Yeah, sure. Traditional, you deploy a static microservice. It is, you deploy it, it runs. When you want to update it, you kill it, you deploy a new one. This is pretty classic. With AI ops, though, you've got a multi-billion parameter model across multiple nodes. That's a difficult deployment, especially if you want zero downtime. And if you're looking to do a complete like A/B style, you're going to have to double your infrastructure costs, and that's going to be very difficult if you can even find the necessary and required hardware to do so. And so these deployments are going to have to undergo kind of a complete refactoring in understanding how we can deploy these massive models and still support our stakeholders. Changes in upstream. This is pretty classic. I mean, everyone, understands with traditional, you have libraries, packages, whatever, maybe even base images you're using from Docker Hub. If those change, you need to make sure to understand when and the impacts. But now with models, everyone's loving, pulling from Hugging Face and all the other areas, and it's a new paradigm. And if they change, it may be very subtle, and you have to have a very educated and experienced team to be able to detect those changes, understand the impacts and the consequences, and adapt accordingly. And a lot of times you have to do it fast. Classic example is ChatGPT changes its API parameters. All of a sudden your tools break, and it's not something where you've got a day or two to figure it out. Nah, you got to do it now, and you should have done it yesterday. That's a real problem for a lot of central support teams these days, to be able to predict these changes, be aware of them, and adapt quickly. Hardware clustering as well. We have traditional solutions where we have load balancers, or Kubernetes has services with deployments with replica sets and all that fun stuff. They're scalable replicas, and we're used to that. We're pretty good at it. But now, with AI ops, like if you've got 5,000 nodes behaving and presenting as one with all this distributed data, and your model is growing, so the size of it has to be supported, and your usership may be fluctuating. And so all of a sudden now you've got a lot of parameters that are changing all at once, and any change is difficult because you are changing at scale. Think about Grok. They just launched a Saudi data center with God knows how many 20 racks. Like, what if that explodes? They can't just say we're going to fix this tomorrow. No, there's logistics involved in expanding that infrastructure footprint, and that is not only costly, but you have to have a team that supports it, and you have to move quick, and sometimes not quick enough. So these are real problems that people are encountering today. Everyone is seeing the data center explosion from all of the major companies that they need. There's not enough power for this kind of thing. So it's a real problem that we're facing now, and it needs to have a solution. Otherwise, it's going to hinder growth and innovation. And of course, scaling, right? Single model artifact is deterministic. So what this is meaning, like, it used to be you had a model, it's trained, great, you deploy it. It's very deterministic. It's, you can do forecasting, you can understand its behaviors, and it doesn't necessarily grow to a level that you have to modify your underlying infrastructure, right? But what we're seeing, of course, the trend is new models are dynamic, and they're maturing in a way that you cannot predict. They're non-deterministic. They are self-learning. They are growing. So if you don't take that into account, you're going to have to do, some sort of radical scaling on, with relative frequency, which if you have an ML team, you're going to have to accommodate for that by hiring specialists to understand who can predict this as best they can and accommodate and be nimble as possible to keep your service up. And so that scaling used to be something that everyone talked about and thought they were pretty good at, but now the game has changed with AI infrastructure. And of course, your stakeholders change. DevOps typically supports engineering teams. That's your clients, that's your stakeholders. There are, of course, business stakeholders and operational ones as well. But the primary, client base that drives your requirements is engineering teams. Well, of course, now you have ML teams that you have to support. And a lot of times the ML ops team is the DevOps team. So they have to support both the traditional engineering teams and the ML ops teams, plus external input from users. And I'll give an example that can kind of illustrate the complexity of that. Here, the Netflix recommendation engine, right? So you've got a couple factors when it comes to that. One is new releases, right? You're going to actually probably increase the weight on the importance of those because you want people to watch what's being released. But you have to new releases are coming every day, every week, right? So you're going to have to include that into your model. So your model's dynamically changing and growing with all the new releases. Also, client choices. You're going to have to take into effect 2 calibers of that, right? And overall client choices to say lots of people are watching this, and your choices to say, hey, I know you've liked previous things similar to this, so I'm going to recommend this to you. So you've got multiple inputs going into a model that is constantly changing on a daily basis, and it has to be so adaptive and complex because there are millions and millions and millions of people contributing to it on any given second. Just look at Netflix stats, it's insane. And also all this is happening, you have to be testing it in flight, you have to ensure high levels of accuracy, and God forbid something screws up and you taint the model and wow, you're in for a bad time. That's going to be really hard to repair. So this complexity is it's already a reality. It's getting more and more pervasive into all of AI, and AI infrastructure and architecture has to be able to support these use cases in order to make sure to provide a service and maintain your SLAs. And of course, things are always changing. And I've been doing, Mike was able to age himself. I will too. I've been doing DevOps for, 18 years. And I'm probably just an infant compared to a lot of people who've been doing it longer. And in terms of like supporting engineers, I've never seen change so rapid in my life, and it's impossible to keep up with. I have to use Notebook just to read articles on the daily to keep up with it because there's not enough time to read. Things are changing so fast and you can't adapt, or at least it's a struggle to adapt. You have to pick and choose what you're going to allow to enter into your sphere of consciousness because it's just too much. So this again is a problem. There's no one who has mastered AI infrastructure because it's so new and it's always changing, and we're all just kind of sitting there saying, oh man, there's a lot of complex issues that we're going to have to figure out here. All right, so that was an extremely fast version of this. I'm sure I missed a lot. Everyone probably has opinions, but I'm open to any and all questions, so fire away. All right, thanks guys. So hit me up on LinkedIn, and if you want to, the bottom right QR code is check out my book.